Good afternoon, everyone. Welcome to our second session on the relationship between artificial intelligence and FAIR. In the morning, we discussed AI for FAIR, and now in the afternoon, it's the other way around. How can FAIR contribute to more trusted AI? And we identified three objectives for that panel, which should guide us through the next 75 minutes. And the first objective is the evaluation on how FAIR metadata enhances reusability, openness, and builds trust and transparency in AI. That is, how can FAIR be used to develop or enhance trusted AI? The second objective relates to the demonstration of the role of FAIR data in fostering responsible and equitable AI research, while reducing the risk of misuse, bias, surveillance, and concentration of power. That's number two. And number three relates to insights into how fairness by design can be embedded into AI workflows. We have four speakers here on stage. They will all give an impulse statement. And after the fourth speaker, we will enter into the discussion with the audio. You have, that is me and Carol, moderating the session, and that is not on purpose that it doesn't continue. No. Yeah, and we have a Slido prepared. So you can either use a Slido, and please select the Charleston room, not theater room, because otherwise your question will end up in a different room. And of course, you also have the possibility to raise your hand, and we have a microphone here, and ask your questions to the audience in person. So this is the QR code for Slido. Depending on how the discussion goes, we also have prepared two questions on Slido, just to see what is your opinion on specific topics related to the objectives of the panel. So you all have scanned the QR code. If not, there's also a mic for questions. Now, let's come to the first speaker. It's Jean Hill. Very welcome, Jean. He's the co-founder and CEO of Sense Science, and at the same time, professor at the University of Toronto at EPFL in Switzerland. So these two affiliations he has. And yeah, I would like you to take over, and the floor is yours.
Great, it's great to be here. And this morning we did have, I think, a really great conversation talking about AI for FAIR. And I think now this session, FAIR for AI, I think is an interesting question, both in terms of all the issues that were just raised, but also what does it mean to make a version of FAIR that is relevant and useful for AI? And I kind of see these really going bi-directionally. Why FAIR needs AI and AI needs FAIR. So I'm a neuroscientist. I've been dealing with lots of neuroscience data and how to integrate it for many years. I got very frustrated by the state of scientific data, which is what led me here. And one of the challenges when building a very large knowledge graph of neuroscience data that we encountered was that it's really, really hard to do manually. And when you're hiring stewards to do this, and you've got different stewards doing different parts of the work, there's a lot of inconsistency, and it's very slow, and it's painstaking. And we need data stewards, but we also need them to have the right tools to be able to do this well. And because it takes weeks of curation, that validation, that curation delays data sharing. There is, even though we worry about AI bias, there's also human bias and missed context, and not necessarily having the depth of the domain knowledge, even if with an expert data steward. And then, of course, it's just not scalable to do this for all of the data available. We don't have enough data stewards. So we need tools that can help scale the work of data stewardship. Now, AI is, of course, a key to making FAIR work because of that, because it can automate metadata and standards compliance. It can accelerate the curation down to potentially minutes, we'll see. It can help link data set and fill in missing context. It can ensure that this is maintained and over time as well, that the FAIR representation continues to evolve. But to do all of those things, FAIR must also evolve for AI. So we do say, yes, FAIR in the original concept is about actually being AI ready, machine actionable. But to go from principles, as it originally started out, to how do you actually implement it to be truly AI ready, that does require an evolution of AI. So you need a machine readable semantic metadata package by design. You need interoperable formats that are ready to feed into AI pipelines. You need transparent provenance and ethical data reuse guidelines that are both machine readable and human readable. And you need a closed loop here so that both AI is creating fair data and fair data is enabling better AI. And so I want to give just a quick example of a system that was recently announced, recently launched a couple weeks ago, that uses AI to build FAIR packages, and we call that FAIR squared because it adds the AI ready and responsible AI to FAIR. And this is deployed on a frontier system where you log in with a Loop account. You need to have methods documenting your data. You need to have structured tabular data to start. And with that, you log in either with your ORCID or with Loop, and you get met with Clara, an AI data steward, who sets up your space. And basically, you have a chat window to the side where you can interact and ask questions about the curation process and maybe work in your own language. But what does that mean to make something fair squared? Then you drag and drop your methods and your data, because the methods are an integral part of understanding the data. They cannot be, you cannot share data usefully without the methods. Here's an example of the data. This is just from the World Health Organization website, an example of tuberculosis burden data and the methodology used to estimate that. And that wasn't touched at all. You don't need to structure this in any particular way. You've got a PDF, and it doesn't have to have any particular order to it. But then the system will go through and make an understanding of, well, what is this data set about, and validate that with the user. And once you approve that, you continue on to curate this, to start organizing all of the methods into a standardized machine-readable form. You are always in the loop to go in and edit that, validate that, approve that before continuing. And once you've done that, it builds a data dictionary, descriptions for each variable, the data type, the units, as well as the relationship to the methods. So linking each variable to the methods that define its creation, so that you really have a contextualized understanding, not only you, but the machine, the AI representation. And of course, the assistant is there just to help you improve this process. Then Clara will propose a set of visualizations based on the context, based on the domain. What are some effective ways of visually summarizing this data set to share with others? And it will build up a whole selection of those visualizations, which you can choose, you can edit, you can say, I don't want this one, I want to reorganize the order here. But this gives you a very rapid way of getting visualizations that then communicate to other scientists, what is this data set about? It's not about publishing scientific claims, but that lets you build up a data article. So an article that describes the data, not that makes a scientific claim. And all of that is a part of making this a very well-documented data set, so then it's accessible to other scientists, and that there's also the guidelines on how to responsibly reuse this. What are the limitations? What are the biases? What are the issues that need to be taken into account in the reuse of the data set? And so with that, you have this visual overview, it's a section of the paper, and you go through and review and approve or edit each section, and then it will build a data explorer for you. So another way of making this accessible is to have an interactive data explorer with a data brush and filters so that others can come in without having to download any software or even download the data set, interact with the data set, be able to take a look at it, see if it's relevant to their research question, as well as then the data certification table, the FAIR Squared certification, and so on. So in the end, you end up with a number of products out of that process. A FAIR Squared data portal, and we'll see if that video starts or not. I don't know. Is it going to start? Ah, there we go. Starting. And so what this is the interactive data portal that's online. This is actually published, peer-reviewed and published already, with all of the contributors, all of their ORCID IDs, the abstract, and then a data explorer that's tailored to that specific data set. So it's got, this is in the case of 30 years of marine measurements off the coast of the Basque Country in Spain, and you have a data brush where you can look at when were these different samples taken over time. And all of this was AI generated, right? So this is something that then the user is in the loop to decide what is a useful way to visualize the data. How do I make this available? But they don't have to have the technical coding skills to build this. And it can happen in minutes. And then you've got all the metadata is populated. So all the standard metadata to be in repositories or be published to DataCite or be submitted into other repositories. For example, we do submit to Zenodo. So all the data is long-term guarded, as well as then hosted in the cloud. This is the certification table for how is it FAIR Squared compliant, so specific statements about how does it actually fulfill the FAIR principles, as well as AI ready and so on. The full data dictionary, all the links to the methods, plus all the contributions are part of this. Now that's a lot of information, but I think that is what is essential to go with data when it's shared. You need all of this contextual information. This is all the metadata you need. And if I can advance, I think it's just switching back now to the, okay. But there is also, well, I'll mention it, but then of course the AI assistant is there to answer any of the questions from all of that metadata. So if you want to know how a particular variable was measured, you just ask. If you want to know what does this mean to me as a policymaker, you just ask. If you want to know what does this mean to me as an 8th grader trying to understand this for a school project, you ask. And it's able to relate. This, to me, is true data accessibility. Skip ahead. I'm going to keep trying. It also comes with a Jupyter notebook, so that then anybody who wants to have code examples in Python, how do you load this data? How do you actually use it directly? Plus that compliance certificate. And I think this is really important to give direct evidence, specific statements. How does this fulfill the criteria of FAIR, plus the AI readiness, and all of the responsible AI statements? How can this data be responsibly reused? And I think that's an essential piece. Now, all of this is built on that, what I was talking about at the beginning, a specification for how you implement FAIR for AI. We call that FAIR Squared. It's an open specification. It's available at this website. It's built on top of ML Commons Croissant, the JSON-LD RDF with shackle validation, using W3C Prov, scientific data units from QUDT, the credit taxonomy. All of those are existing open standards. We did not want to invent anything new. They exist, and they allow you to make this ethical, transparent data with all the methods involved. When we were talking this morning, we were talking about quality. How do you assess the quality? The way you assess it is, yes, the reputation, all of these other facts, but the details of the methods. If you believe that they did the methods and they provide sufficient detail, you're able to judge as a fellow scientist in that domain whether or not this is high quality data. And then of course, you look at the data, you visually inspect it. So with that, I'll end, but I think that kicks us off just to have a robust conversation about FAIR for AI.
Thank you very much, and we come to the next impulse statement to be given by Fotis. He's director of the Bioinformatics Laboratory at the Institute of Applied Biosciences at the Center for Research and Technology, Hellas in Greece. So the floor is yours.
Thanks. Clicker. My turn to try this around. So thank you very much for the invitation to give a very short impulse statement on that. So I'm Greek, which means I have a fondness for history, which means my next 3 slides are going to be a bit of a history context. And I'll start with a year ago, in Berlin, EOSC Symposium. And these are some of the statements that our keynote at the time, Professor Lane, actually highlighted. And it was about how the FAIR principles can and should be adapted to address AI models and data sets. This was as part of the wider NEAR task force output, but there are 2 elements that it really resonated with me at that time. The one was that among the key findings, one element was that rigorous AI is not possible without trusted, transparent data resources. The key word, the important word for me here is transparency, and I'm really happy that Sean highlighted these elements as early beyond, because all of those elements, and you can see in the example elements below in the theory of change, these are all things that can build on top of FAIR services to produce what is a possible AI product that you can trust, that you can rely on. This is today, so it's a very fast history lesson. And right now, what we're discussing in the previous session and now is how to move from FAIR data into something that resembles trustworthy AI. And I really feel that I'm reinforcing the impulse statement from before, that this is effectively done, pretty much everyone agrees, through transparent reporting. We need to be absolutely clear, transparent on what is the process that took us from the data collection, from the data itself, understanding the data up until the point that you generate the model, including all the individual steps. So we're starting from the standards of those individual elements, and there are a lot of services, a lot of standards out there that you can rely to get this high-quality information. FAIR sharing is one of those. We have the Hugging Face to get access to metadata, structured models. You have the ML Commons, you have the Croissant. All of those are pretty much community established standards for all those individual components of the AI process. And these standards facilitate, to an extent, the way that you can do the reporting. And again, we have the very general templates that you can see on the right-hand side. This is a part of the EOSC templates. The generalizable ones, like the one on the right-hand side, which is the DOM registry by Elixir, that it's generalizable to an extent. And by using these standardized ways to reporting, to certify to an extent that what you're proposing, what you're highlighting is clear enough and transparent enough to a level that the community accepts its completeness, you can move one further down to the stack and say, okay, we can define this as part of a policy. It can facilitate the definition of policies. And vice versa, by having a policy, and we have now, especially in the European Union, defining a lot of policies in our AI, these can rely on both the reporting standards, which in turn rely on the community-driven standards for the individual elements. And this gives me the opportunity to talk what I will hope to see in about a year from now, somewhere in EOSC Symposium, wherever it will happen. The quote on top is from physics. So if you ask a layman what is gravity, this is usually the definition. Whatever goes up at some point will go down. It's the easiest, most relatable example of gravity from a non-physicist. And the problem right now is that people use machine learning, use AI in a similar kind of context. They know that there is something there that you can track. You don't have a clear definition. And this is where the challenge is. And this is how the FAIR principles and how EOS can really make a difference in a year from now. Because we have a lot of the underlying elements, a lot of the services, we're talking about data versioning, we're talking about code versioning. These are the FAIR data services, the FAIR software services. And on this stack, we need to also include about the FAIR AI services, from reporting to standards and how this can be replicable in a wider context. And I think that's my quick and dirty version.
Thank you very much for this. We come to our third speaker, Susanna. She's professor and academic lead for research practice at the University of Oxford in the UK. Susanna, the floor is yours.
Thank you very much, Klaus. Thank you so much. Okay, so continue what the previous speaker have said. I want to put an emphasis on our responsibility for good research data management, that at the frontier of AI doesn't stop, actually should deepen. So as AI grows at scale and in autonomy, we need to ensure that we continue to adhere to the FAIR principle, so principle doesn't become an old things of the past, because we need to ensure that the data set that we feed to the machine, the model that we build or the machine builds, and the decision that we extract are still open to scrutiny and collaboration. And to me, standard, which we already have heard mentioned by Sean and by Fotis, are really at the core of the FAIR principle. Let me use the AlphaFold example because everybody knows it. So as we know, the protein folding problem has long been one of the holy grail of biomedical research. And finally, the AI has cracked it. However, we need to highlight two important things. First of all, was the necessary shift from what was initially a proprietary infrastructure to an open, transparent infrastructure so that the community could build on this breakthrough. But the second point, which has been mentioned in the session earlier, is that the AI did not use raw data in the wild, to make this breakthrough. The AI used highly curated, expertly curated and structured data and metadata stored in an open repository structured by a professional expert, the curator, and biocurator in this way, in a standard format called the MMSIFT. So this really shows that the standard, this type of standard and open infrastructure, really act as the link between the human understanding of us in a certain domain and the machine intelligence. Now, we talk about standards. Let's look at numbers of what is out there. So across all the disciplines, there are over 2,000 standards for reporting and sharing data, metadata, experiment, instrument, process, workflow, you name it. So there is around, in terms of number, you can see there, we talk about reporting guideline, we talk about model format, we talk about terminology from simple control vocabulary to rich semantics, ontology, identifier schema, and they have a complex life cycle, and they are very dynamic. Many of them are ready. Some have been deprecated, superseded, extended. Some other are uncertain, which means the community developed, but perhaps, I don't know, they ran out of funds, they changed direction, they didn't get buy-in. So some of them have uncertain nature, some are in development. And if you look at the number of standards which are implemented by a database, a repository, a knowledge base, less than half are implemented, which means the data that is annotated with that standard, it's not as rich as it could be. But if we then look at, these are the type of standard that will make data set AI ready and fairer. However, there are standards which are making AI system fairer because there are standards and repository which have been developed to describe and share AI component or part of the AI R&D. Sorry, too many acronyms. So under FAIR sharing, we created a collection which is growing, and there is around 39 standards at the moment and 13 repository. I think what's really important, if we look very quickly at those, I'm not trying to make sponsor any or to make a full list, but if we look at them, we can see that the majority are either domain agnostic, which is great, but there is a lot in the life science, which seems to be the most active in that area. And this really reflects also the number of standards that make data set fair. The life science seems to be the more active, historically perhaps. And if we look at the example of standards in the life science, we have things which are like CLAIM, which is new. It's for a checklist for artificial intelligence in medical imaging. But there is one like SPIRIT and SPIRIT AI, which is an extension. So this is clinical trial protocol. So the community extends an existing checklist with the application to AI. And that's a good practice. So keep extending standard, keep maintaining standard if the community behind it, it's active. If we look at subject agnostic standard down here, I want to highlight only one, the FAIR for ML, which is a metadata schema being developed under RDA. It's an extension of schema.org to represent trained ML model. If we look at the repository, and you understand why I voted no if you were in the previous session, because I don't want another registry or another repository of AI components, because there are many and they're growing. In the life science under Elixir, we had the Rome registry that stores annotation for a published paper on ML technique. Or if you look at subject agnostic repository, registry, and etc., we have, okay, the very popular Hugging Face where you can find everything from dataset, model, training, etc. But there are even, for example, an example of an instance of a Dataverse for an institutional, as an institutional repository, they store information about AI. So institutions are getting up, closing. So what's the point I'm trying to make here? I'm trying to make that AI is racing ahead. So we need to speed up the development of best practice and key infrastructure like the standards, because standards are the stitching that holds the FAIR scaffolding together. And the FAIR scaffolding is essential to make the AI ecosystem transparent, like Forte said, and perhaps even trustworthy, but definitely transparent. So I wanted the EOS to put a spotlight on the standard, but in a way that has not been done before. We talk about standards. Standards are everywhere, in every document, in everything, but do we do enough about standards which have a complex life cycle? They need to be built, they need to be strengthened, they need to be expanded, they need to be extended, and they need to be adopted, they need to be sustained, perhaps even retired and replaced, but sustained in one way or another. So we need to treat them as infrastructure, and we don't do this now. So I hope that EOSC will take the message. Thank you.
Thank you very much, Susanna. And we come to our last speaker, to Ellie. She's a digital librarian and research associate at the Institute for Management of Information Systems of the Athena Research Center, also in Greece. Ellie, the floor is yours.
Thank you. Hi everyone. All right. Straight to the point. Addressing FAIR principles for EOSC in the era of AI. I'm very glad to be co-chairing the FAIR Metrics and Digital Objects Task Force in this last, let's say, iteration of the task force, and I'm happy also to share with you some of the results and the things that we are doing. We have 55 members already. Mark Wilkinson is also the other chair, along with me, helping. Well, I'm helping. He is the father, among others here, of FAIR principles. But we are all gathering together to try and harmonize some of the inconsistencies and of the gaps that we see in the ecosystem. And some of the reflections from past, from the lessons that we've learned is that, and these are from surveys that we have, you can find them all on the web if you go to the EOSC Association Task Force page. You can see that the people that are more confident in how they assess their FAIR data are mainly those that are curating them. Is this? I found it. Mainly those that are curating them, so data stewards, custodians or curators, data quality practitioners, service data providers, and policy decision makers. What is very, let's say, abnormal, it's the standard makers, although they need it, they are less confident in how they assess fairness. And many more that you can, of course, browse in the respective report that we have. Other thing that we have noticed is that FAIR is progressing, FAIR is everywhere, but still there's need for more guidance from funders, from institutions, from all the different related parties that are involved in the FAIR ecosystem. Support in terms of guidance and training materials, but also in terms of funding. One of the key things that we have addressed through the OS Trails project that I'm happy to be coordinating is the inconsistency in the FAIR assessment outputs across tools. Again, you all know, you might have heard me before saying that if you take the same data set and you try and go and assess it in different FAIR assessment tools, you get different results. That's because the metrics, although they're there, RDA has a fairness reference model, right? It's interpreted differently by different providers. And if we don't know how they interpret it, then that's where we lack of understanding the results and why they differ when you go from one provider to the other. That doesn't mean they're doing something wrong, right? If we have transparency on that, we will be able to understand better how the scores and the guidance coming with the FAIR result can be understood by us. And also another thing that I wanted to stress is that during this work, we realized that FAIR data and data quality are used interchangeably. And this is something very important. We need to distinguish the quality measures, let's say, that are outside the metadata and outside what makes a data set FAIR ready from other quality measures like those that are needed, for example, for AI. Now, the hard truth. A dataset can be FAIR, yes, can be consumed by machines, can have all of it. You can find it in the EOS catalog, has open licenses, you know how to get it, and standard format, great. A clear license, I know how to reuse it. However, it might be biased, completely biased, because the data might have come from a single demographic group, so it's not representative. There might be historical biases, and we see that a lot. It's the first example when you go to the AI talk, they show these nice examples where, with historical biases. No documentation of data curation, of course, and data curation is super important for AI, and no accountability who, what, where. So what we are still not addressing are the bias assessment, curation quality, ethical context, and accountability frameworks. What else is needed? We have this that we are working now in EOSC. We have FAIR and open data. You can see how these principles intersect, what are the different elements that they are addressing, right? Findability, accessibility, interoperability, reusability, transparency. I didn't write for the openness. And this is for a very interesting work that has been done at Microsoft, the FATE in AI, which stands for Fairness, Accountability, Transparency, Ethics. I thought I could give you more acronyms to work with. And why I'm adding that here? Because there are some similarities. You see that both are talking about transparency, both are talking about data documentation, and we have here, if you see, they have already a data documentation standard, no, not standard, but it's like a data management plan, but for machine learning. It's called Datasheets for Datasets, and it has all the information that someone needs regarding the context, the composition of the data distribution, the methods, everything. So it's a set of questions that you go through if you are a data consumer or a data creator, and it helps you have faith in AI, basically. And I think this is where this is a very good collaboration, let's say, of the two worlds, collaboration point, because if we can, since we're talking about machine actionability, if we can take this list of questions and see what are the metadata that we can capture in EOSC, then this is already a good starting point, in my opinion, to getting more metadata that we need for AI, for FAIR and FAIR for AI. Is that all? No. Researchers, and this is from my experience, biased experience, because it's only from one demographic group, Greece, because we see that researchers are very much aware, ICT especially researchers, are very much aware. Some of, maybe many of you are here, you know what to do, how to build the pipelines, how to input the data, and all of that. However, there is a huge gap on what that means on the outside the technical part, let's say, on the ethical part. So what are the regulations or the latest protocols, especially, and stuff. So there's an opportunity here for all of us to move EOSC from being, like, let's say, a data storage infrastructure to becoming an enabler of trustworthy AI. Oh. And this is, in my opinion, 4 gaps that we could all together tackle and collaborate on: training, tools, accountability, and incentives. So I leave more for the discussion. Thank you very much.
Thank you very much, Ellie. I now would like to invite the panelists to have a seat there, and we enter into the discussion with you. And please allow me to kick off the discussion with 2 questions I have prepared, which kind of bring together the presentations we have just seen. You can sit in whatever order, so that is just fine. So, and I would like to start with the hard truth with Ellie, who pointed out that a data set can be perfectly fair and completely biased. That is certainly true, and we got the same insight in the morning session already. And now the question is related to EOSC. Well, if we define FAIR to be the metadata standard in EOSC, can this standard also be a trust mark for AI datasets? AI datasets are datasets which are used in tools for any like AI methods. So is the FAIR metadata standard a good instrument to become a trust mark for AI? Ellie first, and then of course all the panelists have the option to comment on that question.
Okay. Thank you for that, Klaus. I think the question is, yes, of course. It's a very good framework to have technically, to be technically ready, let's say. Of course, as we discussed, we're missing the more provenance metadata, more things that are needed to feed EOSC if we want to trust that this data can lead to good applications, let's say, ethical applications. Yeah, I think what I see is there are, again, what I said, 2 worlds, the AI world and the FAIR world. We are the experts for the FAIR and the open, and there are people that are experts for the AI. So if we can take what's already there, like the datasets for datasets, for example. It's something that is widely used by machine learning engineers, right? If we take it and we verify it, like try and understand where FAIR principles are inside these datasets for datasets, I think that's a very good also promotion of the FAIR principles throughout. So yes.
So yes, Fotis, do you agree on that? FAIR can be a trust mark for AI data sets.
I would argue that FAIR is the bare minimum. It's not, in my mind at least, if you don't have FAIR data, you cannot do too many things after that. So it's your baseline. If you want to talk about trust AI or ethical AI or anything else on top of that, I would argue that we need to be a bit more rigorous in the expectations of the data itself. So FAIR, obviously, non-FAIR is out of the question. It should not even be taken into consideration, but it's not sufficient. It's not a trust seal equivalent thing, I would argue.
I go through Susanna and then Sean.
It becomes easier and easier because I agree with Fotis. You know, it's the beginning, it's the bare minimum. Maybe we have to have several checkpoints where we know that the machine is actually maintaining the fairness as it chunks and reads the data and elaborate and create more data. So making sure that the fairness at the beginning, it's somehow maintained throughout to ensure the transparency. And I think that is the word. Not definitely trustworthy. I don't know if I can trust it, but I can see what it's doing, and it's the necessary start.
Yeah, I mean, I think one of the challenges is that FAIR is not a standard, and so it's a set of principles which I think we all agree with. We all think they're really good, but how do you actually implement them? What does that actually mean? And the fact is every single data set is biased. Right? There's no such thing as an unbiased data set. Now, what biases the data is the process by which it was collected. So if you don't capture the details of the process of how the data were collected, you don't have any information to inform on the bias, which is an essential part of reuse. So I would say FAIR alone cannot be a seal of any kind of trust. It needs to be something that ensures that the process by which the data was collected is actually really well detailed and then reviewed and judged, I think.
Then the next question goes to Sean again because he has a practical implementation of FAIR Square. And Susanna addressed in her statement that AI is racing ahead of the development of best practices. And that brings me to the question, how can we ensure that fairness remains a continuous process and it's not a one-time compliance exercise? And maybe, Jean, you have experiences in FAIR Square with that phenomenon that data changes and it's not enough to have it made fair at one point in time. So maybe you want to explore that.
This is alive,
yeah.
Yes. I think it's a really important point, important question. And of course, we all have the experience of going to a data repository, looking at something that's 10 years old, and just being like, how am I supposed to figure this out? There's a huge opportunity to have processes that are in place that are automated to keep updating the data model, for example, with the latest FAIR standard, whatever that may be, but keep that up to date and then check that, run tests on it, run automated tests, make sure that this is alive and well, and if there's an issue, flag it because it needs to be reviewed by somebody who knows more about the data set, like the data owner, if they're still around.
And Susanna, you raised that point. Do you have a recommendation to the EOS community how we can ensure that fairness remains a continuous process?
Yes, and building what Sean was saying, we need to insert these checks within the workflow, the AI workflow. The problem it becomes is, what do we use to do these checks? And, you know, Ellie has highlighted the assessment, the assistance that is being organized and standardized. The only thing is that, you know, again, I want to go back on the topic of the standard, which are important, these assessment in these checks. But the standards, some of them are domain agnostic and perhaps easy to include and guess which they are. But when things become discipline specific, and you can imagine I start my journey, from one discipline and build into another. So I'm moving across disciplines, across expertise, and that becomes using discipline-specific standard and discipline-specific expert and discipline-specific assessment in a way. So this is what we need to try to build. How we build, I have no clue, but we have to.
Otis, you have an opinion on that?
The fact that I have an opinion doesn't mean it's a good one. Yeah, well, in my mind, the key challenge is to have an agreement of what the standard might be. What Susanna demonstrated earlier is that we have already too many standards and that we continue producing them. So the power that EOSC community can bring is create a consensus that we as a community, either within domain or domain agnostic, depends, we have thematic nodes, we have too many things right now that are quite well specified to an extent. We agree that this is the set of standards that we agree on. It's not going to be unanimous, but at least it will have the support of a much wider community than 50 people from one consortium or one country saying that this is it.
Ellie, I very much enjoyed being the board liaison for the Fair Objects task force, which is well managed under your and Mark's leadership. And has the dynamics of the data been addressed in the Fair Metrics task force? Is that an issue, what we are currently discussing here? The dynamics and how can we ensure that fairness remains a continuous process and is not just a one-time event?
Well, this is very challenging.
Yeah.
So this is not something that we are currently exploring in the task force. Okay. Currently, actually, what we're doing is very interesting now that I have the chance to say. It's concentrating on what metadata we're missing when we're assessing data. What we see is a huge difference depending on which repository you go. If you go to an institutional repository that is based on self-archiving, for example, you find metadata only about the record, like the descriptive metadata. And if you go to well-curated infrastructure data repositories, you find more metadata about the data themselves. So there's a huge gap there already that we are solving, which is, we are recommending how this can be solved at least, which is good. But what you're saying about the dynamics is a matter of the OS Trails project work. And we have a fairness reference model that we have out. It's been, it shows how how the different components of the fair assessment tool should have what are the metadata for the model, for the algorithm, for the results, etc., so that you have transparency in the results at the end. And this has been a very successful outcome for the EOSC because it brings standardized outputs across the major fair assessment tools.
We have a question from the audience in Slido, Carol.
Yeah, we have several.
Okay.
Several questions, but my mic is not working. Can you switch? Yeah, now it's working. Several questions related to the talk or the presentation of Sean, and I'll combine them. So the question is this Fair Square for free for researchers? Is it open source, or do you need credits? Then is the Clara AI Data Steward open source as well? Part of the same question, more or less. And what are the data management processes building Fair Square, and where can they be found?
A lot of good questions. So the platform itself is a commercial platform. It's proprietary. What it outputs is completely open. All of the data that is and the data model that's populated is all open access. The data is deposited in open community repositories like Zenodo, but Clara, all of that is a proprietary service that is first being offered by Frontiers, the open access publisher. So the model is that we've partnered with a publisher to get this out into the world. And that's valuable because there's then a data article that incentivizes scientists to actually publish their data, to get their data out. They get credit for it. That's not the end of the story. So that's the starting bundle, is that the whole service is offered for a fee about the level of an article processing charge or for publication. But we're actually here to learn more about other possible models and discuss other ways that, for example, it could fit into the EOSC infrastructure and different ways of packaging it. Did I miss something from those questions?
No, I don't think so.
There is a question. Could we bring the mic to the middle of the room?
It's just not a question, just a comment on what you said, Shane, just to show the complexity of what we are talking about. So Frontiers is a publisher, okay? So you mentioned some services, right? But on the other way, Frontiers is seen as a publisher just in a gray area. So in some areas, it's seen as a predatory publisher. In some areas, it's not seen like that. So it's just to show that it might, among the community, it might show the complexity of all of that. So what you said about the services is absolutely true. But if we are talking about the apparatus, just like we were talking this morning, the intention, the interest of Frontiers as a large group and a publisher is maybe a bit larger than what has been presented. So again, just to show the complexity of what we are talking about. And of course, the research community has to keep that in mind, clearly.
Maybe just a quick response. I mean, I think, the intention is not to keep this to Frontiers only at all. And, we've had a lot of good conversations with, for example, repository owners and others that are very interested in this as being a way to encourage data getting into and make it easy for scientists to get data into the repositories.
Another input from the audience, please.
Yes, it's about AI model, as Sean presented. I think we have to take very serious the way that we working with AI, because we need to make AI explainable, not only for a machine, but also for humans. Then we have this paradox, and I try to encourage in EOS to do an AI in a responsible way and an explainable way. It's just a comment.
Okay, there are two further comments. Vanessa first, and then you in the first row. Behind you, Vanessa Proudman.
Thanks very much, Vanessa Proudman, Spark Europe. It's a question for Sean. I'm wondering about the governance plans for this, because I think, so you said you wouldn't want it to just stay with Frontiers, and I think probably a lot of us would share that view. So it would be important to see, what are your thoughts and plans there? Thank you.
So I guess first of all, the Fair Squared open specification is open and published on a separate website, and then will be what we're doing now is having conversations with different groups to say how would they want to be part of the governance of that. So we want to establish a community governance model for the open specification so that we could make sure, for example, as CoData or RDA or different groups are developing new domain-specific pieces or other interdisciplinary pieces, that we can make sure that it's aligned with those developments. So I think that's one very key piece. And then, I think the other part is just to look at, well, what are the different models of engagement that the community is interested in terms of, where this service could be valuable. I think it's really just a matter of understanding the opportunities.
Okay, I would allow two further questions, and then I would go to a Slido, one here, and then the lady in the back.
Good afternoon. Thank you very much for your presentations. I'm a bit lost because this title AI, actually we are missing a definition of what AI. I do believe that we've got AI in this symposium because we are all thinking about Gen AI. So I do recognize that for machine learning, deep learning, we need fair data, and fair principles have been designed for humans and not for machines. What I see with Gen AI, and that's the hot topic, is that basically Gen AI doesn't need fair data. It goes on the web, or we can consider that the web is fair by design, findable, accessible, interoperable, and reusable. But what we are missing, I think this is what you said, was about before the meeting to comment these fate principles. We need data that we trust, because when we are using, and we are all using as scientists, Gen AI, different models, Bio, Mistral, and so on, we need to rely on this tool. Otherwise, we can't progress. I would like you to react on this.
Okay, who wants to go first?
Maybe I start quickly?
Yeah.
So in fact, in my mind, because I'm a modeler, a computational modeler, and what I wanted from actually making the data fair, or fair squared as we ended up with, is something that I could plug into a machine learning pipeline, not something that was Gen AI ready, although it is also Gen AI ready. But and that comes from the experience of organizing laboratory data, or transcriptomic data, proteomic data, cellular data, physiology, all of these things into a form that I can then feed into machine learning pipelines. So that requires a level of scientific rigor that I had not found a solution for before, right? And that's really was the driving force here for this approach, was to make sure you have enough detail in the methodologies so that you can really understand how every variable can be interpreted, exactly how it was measured, because those details matter for every reuse of every variable. So.
Who else wants to comment on that? Fotis, you have the mic.
So first of all, I agree with Sean. At least as far as I can tell, none of those are only for Gen AI. At least the standards that I'm aware of, they are generally defined for machine learning and AI processes in general, not Gen AI itself. The second argument is that, with the exception of the extremely well-known, extremely widely used big large language models, Claude, etc., not all Gen AI rely on the web. AlphaFold, the example that we've been using quite constantly right now, is a Gen AI model that is rely on PDB data primarily, which is very well structured and quite fair by design. So what I would argue is that, yes, we need to make sure that our standards and the way that EOSC will adopt these standards in whatever form are defined in a way that are applicable to whatever models will be used in that context, and not be a generalizable, this standard will fit all. It's always fit for purpose. So that would be my quick response to that.
Ellie, because the fate principles were addressed.
No, I will diverge. I will talk about standards. So you go first, because I want to make a point on standards, which you made earlier, and I didn't have the time to.
Now the panel discusses among themselves. Okay.
Well, thought is coming back to the standards. You said earlier, need to be interoperable, need to be developed. And I want to make the point, which I made in my final slide, that we really do not have a proper model for funding them, for sustaining them, for governing them, for expanding them. And the one that survive, it's almost a Darwinian process. They survive, the one who actually have a bigger community and have implemented in an application or in a repository, or they have data. Or you have all these standard developing organizations like ISO and etc. that make you pay for a standard, take 20 years, or the CDISC one, which are free, but you have to pay for training to even understand how to use them. But then you have all the wealth of community developed one which have no support. Yet everybody say it's important, they need to be interoperable magically. But we don't have a process of doing that. That's it, my rant. Sorry.
And now Ellie.
Okay, two things. One is, I would like to stress the processes. The data, yes, is the input and the output of an AI algorithm, an ML pipeline, for example, since this is the most used, let's say. But the processes, like the processes that you saw with the, with the workflows, like doing this from here, taking the data set from there, this is what we should be doing, everyone in our organization, establishing these processes, managing our data, so focus on the data management processes, and then it will be easier for us to have like tools such as the FAIR squared, or yeah, is it FAIR squared? Yeah, in the EOSC. And another thing, second, is we have the EOSC Explorer, and we will have more portals to find data sets from the nodes, right? Why are we not talking about this data being used to train the models? And we're talking about ChatGPT or like whatever GPTs we might find outside. Because this is, it should be, we should like cater for this data as a community and not allow like public commercial
That's
data.
what I have a Slido for, but we take first the lady in the back.
Well, Ellie already pointed to one of the questions I had, but first a comment. We know the models, AI models are not transparent. People use it anyway. We are not going to be able to stop that. As much as we would like to, it's not going to happen. The second point is fair data does not necessarily mean that it's unbiased. That's also known. Probably that will still not stop people from using those models. So like you said, Ellie, the only thing that we perhaps can control or have some sense of is what data is being used for these purposes, and maybe then having the experts have a say in please use this data for this training purposes. This model is good at doing X, Y, Z and not A, B, C, and those guidelines will probably be able to bring some control of what is being used and how it's being used. I mean, this is even putting aside ethics, sustainability, and all those discussions. It's just good common sense practices. And I would like to, so now the question is, how does EOSC playing a role here, maybe in providing guidelines on the do's and the don'ts? Could that be a role that EOSC can pick up? Thank you.
That brings me to the Slido we have prepared. We want to create a word cloud. And the question to be answered is, in addition to the underlying fair data, what would be a key requirement to ensure trustworthy AI? And can you, so in your Slido there should be now the a word cloud you access, and then we see what your responses are. This one. So we all agree that for like the generative AI we don't need fair data, but what we want to achieve with the EOSC is providing a environment for trusted AI, and we indicated that fair is contributing to that, but it's not the only mechanism or only principle. And here we want to explore what other principles do we have to ensure trustworthy AI. Here's also again the QR code. We have provenance, we have transparency, we have care, and of course the panelists are also invited to make their contributions.
Because provenance and transparency are related.
They are related, that is.
This is great to watch.
Those who have entered either provenance, transparency, and care, I would ask you, well, why? So prepare a potential answer to why you have chosen either provenance, transparency, or care, because it seems to be a concentration on these three principles. Transparency is still by far the largest. So who entered transparency and for what reason? So what do you mean by transparency? Who wants to explain his or her input? There must be someone who entered transparency. There, Ron, please, yeah.
There's no transparency in this polling.
On transparency, at least I meant that you need to know how did you get the data. Yeah? A lot of data is actually being robbed, and so they can be totally fair, but not legally acquired. So what was the process that you had it? I also agree that there is no such thing as an unbiased data set, but you can be transparent. Especially this is the thing in training our own AI models now, is that if we don't have transparency and we cannot prove how we get the data, it's very hard to prove how you get to your results. So transparency in how you get the data is key for us.
Okay. And I see nodding there among the panelists.
Someone else's.
There is another contribution.
I didn't write transparency, but I would. I would have done it if I had my mobile on. No, I think transparency is actually also essential to what we discussed this morning, right? So it's one of the minimal required property to identify some aspects of quality of the data. So without transparency, it's not possible not just to check if the data is legally provided, but which were the tools I used, which were the kind of care the data went through. So this may actually automatize also the process of establishing some indicators. No transparency is just impossible to do it.
Otis.
I'm absolutely in favor of transparency, but there is transparency done well and transparency done bad. I have two examples that are probably very familiar. One is cookies. Transparency, we are being tracked. At this point, I think everyone's just clicking accept or like without thinking, like just get it out of my way. There is transparency, but this is not a good thing. The other example is HTTPS. Now, most of the non-HTTPS, most of the browsers have a red screen saying, are you sure you're going to proceed? This is good transparency. So what I would argue is that we need to define the good practices, and that's actually the argument that was made just a few minutes ago, good practice on how we want to enforce, how we want to present this transparency. Because that will make it that much easier for someone to say, yes, this data is fair, it is biased, and I acknowledge that this bias will be part of my system. This is transparency done well. It's not that we can avoid it, but it's something that we can control about it. Sorry.
There's two comments.
Yes, so again on transparency, so the most important thing in my opinion is the transparency of the training data. So that the training data, when they are transparent, at least the source of the training data. So as well the transparency how the AI modules and the algorithms works, but most important are the training data. And then maybe you can ask a follow-up question.
Yes, go ahead, please, yes.
So and then I think we agree that we not only need fair checkers, but as well maybe fate checkers. But the same problem with fair checkers, for example, the Fuji tool, they can only do automatic checks and it's difficult to check, for example, you cannot check bias, really. So is there, but maybe there's a way to check bias, or it isn't? I don't know. I fear there is no way to check it.
Okay, thank you. I think if we write a good data management plan that goes beyond actually only data, but goes on if we're talking about AI, machine learning pipelines, how they were compiled and all of that, then we already have the information that we want. We will have the methods, we will have the training algorithms, we will have everything in one place. And then there is a big effort, again, biased, I am biased within the OSTRADS project, that we are developing machine actionable data management plans. So if you can take this metadata from the data management plan, which has more things than data, which has all the things that we are talking about, then you can start playing at least with these in the EOSC to see what you get. Because now you cannot have this information in a machine actionable way.
Okay, we have 2 further questions.
Yeah, I would like to come back to this point which was mentioned, that you need a highly curated data because that's the success of AlphaFold. Yeah, not much else. And this is not possible to do by humans, because if we want to go for data, I mean all data, it would be extremely enormous burden for researchers, and researchers should do research and not evaluate all the time something what they actually do at certain level of career. So I would like to point back to your shackle mentioning in your presentation. Is there any catalog of data pattern schemas or whatever, what your shackle automated evaluation is based on, or how you are doing it? Because this would be a way how to get closer to data quality. Bias, as you said, every data are biased, but with a shackle query you can learn about the bias and then it's fine.
Yeah, so the fair squared specification includes shackle schemas. So that's part of, I think you've got a follow-up question.
No, but for each use case, it would be slightly different.
Yeah,
so that's why.
So at this level, for this is kind of a cross-disciplinary core set of schemas. Now, for individual domains, right, that would have to be something developed with those domains, for example, to do something more specific. But typically, what we're looking for is that there's sufficient completeness in what is provided, the information that's provided, and that Clara, for example, on the basis of these shackle schemas, can ask follow-up questions and say, look, I can't continue until you answer these questions. Then the shackle schema is satisfied once the questions are answered, and then you can continue. So that could be extended to domain-specific requirements. We're starting off quite general, though. So.
Okay, we are approaching the coffee break. More free drinks are required, but I take a last question from the audience.
So it's more like comment. So my name is Slava, and I'm co-author of Croissant Standard. So thank you all. We know what to do next, and it's here. So my question is about variables and semantics. Somehow it's not being discussed today that semantics is the most important thing. Why?
Well, because we haven't had time.
Okay.
I mean, the whole model for me, fair squared, is essentially, you know, it's got to be based on something in which you can integrate all of the domain-specific semantics, right? That is at the core why you're adopting this RDF-based model, is that we know there's been a lot of work in lots of different domains developing ontologies that are relevant. We don't want to reinvent anything. We want to adopt good semantic models where they exist. I do think that there is a significant challenge with many ontologies being developed without clear use cases. And I would not want to just ad hoc adopt whatever ontology is out there, but fundamentally the model is set to be extended to any well-designed domain ontology.
And how you feel if AI will be creating control vocabularies automatically and ontologies?
Oh, I think it's fantastic.
Okay.
But it needs to be validated.
Okay, thank you very much for the discussion, for your input. We identified that FAIR has some potential to serve as a trust mark for AI data sets, but we also agree that this is not enough. You can see that here on this slide. And there are further criteria which need to be fulfilled in order to ensure trustworthy AI, and that is what EOSC could serve for. Could be an environment in which you have trustworthy data which is hopefully used by trustworthy AI models that we did not touch. To what extent are the models themselves trustworthy? To have a environment, in which we have explainable AI. We also touched the topic of the dynamics of AI and the continuous process when data changes over time in our systems. And well, we did not really come to a final solution how we can avoid that being fair is just a one-time compliance exercise. How can we continuously ensure the fairness of our data? Thank you very much to all of you. Thank you very much again to the panelists. And now is the coffee break with free drinks. Thank you very much.